Hello everyone, in this video I'm going to discuss the overview of artificial intelligence. So here's what you'll find in this lecture. So we'll start first with what's AI, how is it being defined, what's intelligent systems, how do we design one for us to better appreciate AI, and let's see some of the AI applications currently on the market. Okay, so let's start. So what's AI? Actually, there's no one agreed definition for this AI. So to help us out with, let's see how AI is portrayed in films when we see some AI products being sold in the market. And finally, let's take a look at how textbooks try to define AI. So in films, you had a lot of AI-inspired sci-fi movies. We have Wall-E, a robot with a memory and a personality, and one who collects trash in an inhabitable Earth. So we also have iRobot, where we see robots serving humanity, but ends up being with a major threat to human existence. And also, finally, we have Metropolis, one of the very first AI films shown around, I think, 1927. Here we see a humanoid robot with personality mimicking capability. So another question is this AI? Is robot equals AI? Or there's more to it? Actually, there's been many attempts in creating humanoid robots, and one of the most successful ones is Sophia by Hanson Robotics. Sophia has been interviewed and tried in debates, and hearing her answers is very amusing. In big tech companies, they have also been investing in AI researches and marketing, AI products such as Google Nest, a smart home assistant, and Amazon Prime Air, a smart delivery drone service. So today, AI market has grown extensively in AI researches at the front line. So what's in our textbooks? According to Russell and Norvig, AI is the science of making systems or machines with a fourfold approach. So the first one is through cognitive modeling approach, where machines are developed in order to automate activities associated with human thinking. An example is the social chatbots. And next is through the laws of thought approach, where machines are trained in order to have them or to have the same mental faculties as with humans, such as those used to create AI opponents in games. Another is through the Turing test approach. Here, machines are created to mimic how humans will act and respond. An example is a technology used to develop self-driving cars. And finally, we have the rational agent approach. So the main goal in using this approach is the creation of intelligent systems like the ones used to create smart assistants such as Alexa and Siri. So for this course, we will focus on the last approach, which is the rational agent approach. Okay, so in the rational agent approach, creation of intelligent systems is at the core. So what is intelligent systems and how does it relate to AI? So as said by Stuart Russell, long-term goal or the long-term goal of our field is the creation and understanding of intelligence. Productive research in AI, both practical and theoretical, benefits from a notion of intelligence that is precise enough to allow cumulative development of robust systems and general results. The concept of rational agency has long been considered to fulfill this role. So thus, in building intelligent system, we focus on creating rational agents. So what is rational agent? So a rational agent is anything that makes decision and is expected to perform the right action. So right means agent fulfilling its primary goal. So basically we have an agent that operates in an environment such as this agent has a goal and interacting in a computational environment in order to interact with the environment. So the agent is packed with sensors that can receive percepts as well as actuators which can receive commands and perform actions affecting the environment. So the results of the action done by the agent is compared always to the task in order to determine whether the agent has achieved its goal. Say for example, let's look at the automated taxi driver. So you can watch this video when you get the slide. So here is the link. So you just need to click on this one and open your browser so that you would be able to watch this video. Okay, so and to better understand the automated taxi driver agent, let's look at the description of its task environment. So this rational agent's goal, defined as a performance measure, can be the following: be able to drive the taxi safely, legally, and in a timely manner, meaning you get your customer fast to where the person is going. So next is expected to interact with the computational environment, the driving function. This functional agent or rational agent is packed with actuators like steering wheel, accelerator, and brake, and so on. So finally, to be able to make the right judgment whether to stop or accelerate. So this rational agent is also built with sensors such as cameras, sonar, or radar for measuring distance with other cars, and a speedometer to monitor its acceleration, and so on. So when the task environment is set, the the main job left is to create the agent function. So this maps and receives the percepts with the right action, and here lies rationality. So in designing rational agents, we give great emphasis in the creation of the agent function, so also called as the action selection function. And this is the part where we implement algorithms, learning models, and we'll look at this more in the coming lecture. So for now, let's focus on describing the environment with a rational agent. So this is important since the properties of the environment greatly affects the appropriate agent design. And there are 5 areas where we focus on defining the properties of our environment. So first is the observability. So we say that the environment is fully observable and our agent has complete knowledge of everything in the environment. Okay. So on the other hand, we say that the environment is partially observable when the agent is given only a portion of the interaction or behavior in the environment. So let's try given a chess and a poker game. So which is fully observable, and which one is partially observable? Did you get it right? Yes, the chess environment is fully observable, whereas poker is partially observable only, since you can only know the values of the card you're dealt with. Okay, so next is the outcome dependency. Here we say that the environment is deterministic if any action by the agent has a single guaranteed effect. So otherwise, if it's the same action can have different results at the same time, then we say that the environment is stochastic. So this time, or let's try this time, you have chess and a monopoly game. Which is which? Nice. If you said that chess is deterministic, you are right, since the player's action is the only one contributing influence to the change in the state of the board. Whereas in Monopoly, we have the shuffled deck at the middle and a dice roll. So the next one, or the third property, focuses in environment changes. So here we say that the environment is static when only the agent's action can modify the environment. So if there are processes other than the agents executing in the environment, then it is dynamic. Okay, so let's try chess and an MMORPG. So which is which? Okay, great. If you answered that MMORPG has a dynamic environment, you are correct. So, and then an MMORPG environment state of the environment can change when the player is deliberating with or which action to take. So whereas in chess, wherein the player isn't doing anything on the environment, there's a guaranteed at this state of the next environment won't change. Okay? So the next one is the environment behavior. So this property describes whether or not the environment has a goal of contradicting the player, which is adversarial, or not benign. So let's try it with the environment of an automated taxi driver as well as with the MMORPG setup. So which is which? Great. Though the environment of an automated taxi driver is stochastic, it is actually benign, meaning the environment has no intention of jeopardizing the taxi driving, whereas in MMORPG, it is adversarial by design due to the nature of the game. So lastly, we look at the aspect of space size. Discrete state space only means that there's a finite mapping between percepts and action, while for a continuous environment, there's a range of continuous value being described being described in the changes in the state and possible percept action mapping. Okay, so now guess which among the two is discrete and which is continuous. Nice. So you can guess that the chess game as a discrete environment. You are correct. So this is the game rules of chess. It dictates only which moves are valid and what locations are accessible. So in the other hand, for MMORPG setup, there are a range of possible course of action mapping as well as a seemingly infinite number of possible state changes. Okay, so there we have it. So those were some of the important properties about the environment that needs to be defined before designing a rational agent. Now let's look at some of the AI-based products that are sold in our market. So let's see how AI has been integrated with different aspects of our society. In the fields of robotics, we can see that our robots are already successful in grasping objects and transferring them, but there's much research needed in the area of mobilizing them seamlessly. So we have quite a number of successful machines also aiming for driverless cars. However, we're still quite far from driverless cars. In healthcare, one of the fields that get most research focused on is the automated detection of some diseases. So the medical risk predictions are already available, and there are already a number of successful AI researches. So, but there's still a need for more research on safety and security. And another one is the games. Games is one of the fields that allowed AI's progress, the first bit of display. So today, we already have an application or AI application that can analyze your gameplay and suggest how you can improve. So that's all. There's so much that is not included in the list, but I'll leave that for you to explore. So that's it. You can play this video to better understand if you have any question. So you can send me a direct message. God bless.